a function of that where p is greater than 1. They say, number one, on one set of x's, sketch the graph of f of x and the derivative. All right, show all the intercept and turning points representing these in terms of p if necessary. All right, so that graph we can actually see is a parabola. It's a parabola. First, we look at that x squared. We know it's parabola, smiley face circle. Now they tell me p is greater than 1. Whatever it might be, p can be 2, 3. It's a positive number. That means I've got -1 times positive. So the graph is a sad face. The graph will look down. All right, so I already know the shape is down. Then if I wanted the y-intercept, I'll put 0. So y-intercept, x is 0, and then y is 0. I'm just doing that. Then I'm looking for the x-intercept there. X-intercept, we take the graph minus p, x squared plus 2px. We make that equals to 0. Pull out a common factor. I'm going to take a common factor of x, just x alone, so minus px, then plus 2p, and then equals to 0. So one of the x-intercept, x equals to 0. When I solve this one, it's going to be minus px equals to minus 2p. Then I divide by the minus p, so it's going to be positive, so x equals to 2. These are the x-intercept. Now I need the line of symmetry, the turning point. Line of symmetry will be x equals to minus b. Minus the b, you can tell is 2p. Minus b, which is 2p, all over 2a. A is minus p. There we go. So you can see I've got minus 2p, minus 2p. Axis of symmetry is at 1. So is at 1. Now I might need the y value. Actually, I need to substitute 1 there to get the y value in for the turning point. All right, so I'm just going to do this one because time is failing me. All right, so now when I put 1 here, put 1 here, I'm left with minus p plus 2p. I'm left with p. So this is p, but I know p is positive. Good. Now I'm ready to sketch the graph. I draw my Cartesian plane, and then I draw it there. I said, okay, let's look for the x-intercepts. X-intercept, we had them, 1 is 0, 1 is 2. So it's gonna cut here, and then the other one is 2 there. All right, so this will be 2, and then this one will be 0. Then I need the axis of symmetry. It's going to be the line exactly in the middle of the graph. There we go. And then the y-intercept, there it is. So that dotted line, it's actually 1, and p is somewhere here, somewhere above there. Okay. So my graph will actually turn like that and turn like that. That is my parabola. It's going to turn like that. So the coordinates of the turning point there is 1 semicolon and p. All right, so they wanted me to draw the derivative. Well, if they want me to draw the derivative, I can use the same method. I can derive the equation. It's fine. I can derive the equation f prime x. When I derive it, it's minus 2px and then plus 2p. There we go. It's straight line. So I'm going to make x 0. When I make x 0 here, I'm left with 2p. Twice p. Remember, p is here. So twice p must be somewhere above. I'm supposed to make it look realistic, but I'm not. I'm going to put it there. I'll say this is twice p. All right. And then if I want the x-intercept, that must be 0. So when it's 0, I transpose, I've got 2px equals to 2p. When I divide, x equals to 1. Well, 1 is here by the brown. So the other equation will be the green one. It's going to be that green line. It's going to be that. That is the derivative. All right, because parabola must give straight line. All right, picking at this one, let's see what's happening here. This one says to me, it says show that the points of intersection of f and z will always be independent of the value of p. Come on, we just did that. They say show that the points of intersection of the two graphs. Oh yeah. So that means when you equate the two graphs, when you take this one, when you take that, you equate it with that, the p will disappear. So let's just show them. So I've got minus 2p x and then plus 2p equals to, I've got minus p x squared. When they say it's independent, p it will never be in the equation. Yeah, you can see, you can divide by p. Divide by p both sides. Or take it out as common factor. So the p will cancel. You got minus 2x plus 2 equals to minus x squared plus 2x. So you see, that's how you're going to solve for p, for x here. So the p is gone. That's it. That's what they wanted. So that one is done. It's 3 marks. They never asked me to solve for it. They just say, show that the p will disappear. Then we are done. Done.